Hello. Today I'm going to do a word problem on quadratic functions. So this problem reads, a rectangular playground is to be fenced off and divided in two by another fence parallel to one side of the playground. 360 feet of fencing is used. Find the dimensions of the playground that maximize the total area enclosed. And they give us a hint, write a quadratic function for the area and find the vertex of that function. So anytime you're trying to optimize a quadratic function, it is optimized at the vertex. To get to that quadratic function, however, is going to be a little bit more challenging in this problem. So first, I would recommend starting off by drawing a picture. Draw a shape. Okay, sorry. I'm new to this setup, so I apologize. Okay, let's try that again. We will go ahead and draw a rectangle to represent the area that's being fenced in. And the added complication in this problem is that we are going to fence down the middle to divide that area into two. And so we're going to use 360 feet of fence to do that. We don't know the dimensions of this rectangle, so we don't know the length, we don't know the width. Sorry, I'm trying to change the color here, and it's, I don't know if I'm hitting in the right spot, or there we go, okay. So we'll use variables to represent these dimensions. So I'll call this side x, for example. So this will be length x, and I'll call this side length y. All right, so if this side has length x, the opposite side will as well. Same thing with y. If this side is length y, the opposite side will also be length y, but also the part of the fence down the middle will have the same measure of y. And so if we add up all these parts of the fence, it should add up to the total amount of fence being used, which is 360 feet. So we have two x's and we have three y's. And that adds up to 360. All right, so what we're going to do is solve this for y. So we'll subtract 2x to the other side. We'll get 3y is equal to 360 minus 2x. And then we'll divide by 3 on both sides. I'll go ahead and show that because this is going to take a little bit of work to simplify. We're going to end up with y equals, the 3 divides into the 360 and also divides into the 2x. So the 3, when it divides into the 360, will result in the quotient of 120. I don't know, I was trying to think of a better way to say that. The 3 divides into the 2x, and we're going to rearrange that a little bit to make it look like this. So we'll get 2/3 x there. So we get 120 minus 2/3 x. This is an equation that relates the length to the width, or x to y. So it shows how we're sort of limited. The bigger we want to make x, the smaller y will have to be. But this is not what we're trying to maximize. What we're trying to maximize is the area. So what we need to do is write down the formula for the area of this rectangle that we're trying to fence in. So the area is, for a rectangle, length times width. Sorry, I still haven't got this figured out yet. Okay, I might just have to keep using, okay, there we go. I don't know if there's a delay or if I'm just not, clicking in the right spot. All right, so the formula for the area of a rectangle is, as everybody knows, length times width. But in this case, we're not using L and W, we're using X and Y. So we're using X for the length and we're using Y for the width. So our formula for area in this example can be written as A equals X times Y. So what we're going to do is take our formula relating X and Y together that we have solved for Y, and we're going to plug that into the formula for area. All right, so here's what we're going to do. We are going to switch. I'm running out of room here on the screen, so we'll kind of pick up here on a blank screen. All right, so we have area, sorry, let me get set up here. So we have area equals X times Y, but in place of Y, we're plugging in 120 minus 2/3 X. All right, so this is our equation for area, and now we have the quadratic equation the hint was telling us about. We distribute the x and we'll get 120x minus 2/3 x squared, and that is our evidence that we have a quadratic equation. or a quadratic function, because we have the highest power here of x being 2. And as the hint also suggests, we should find the vertex of this quadratic function. That is where the area will be maximized. Right? So if we want to maximize, let me just go ahead and write that down. If we want to maximize the area, which is the function value here, that will be accomplished at the vertex. And we have a formula to help us find the vertex. The formula is x equals negative b over 2 times a. And this function, b, is equal to 120, so we'll have negative 120 over 2 times a, which is negative 2/3. So you can see here the negative signs are going to cancel out. And this takes a little bit of work. Unfortunately, this doesn't cancel out very nicely here, but it works out to be a nice answer. Once you work it out, I would say maybe just plug it in a calculator if you need to do that. I'll just tell you quickly the way I'm computing it is 2 times 2, because you can think of this as 2 over 1. 2 times 2 will be 4. So then I'll take the 4 and divide it into the 120, and that gives me 40. It gives me 30, right? So the 4 divided into the 120 gives me 30. And then this 3 will get flipped up to the top, because if you're dividing by a fraction, you multiply by the reciprocal. The 3 ends up on top. 3 times 30 gives me 90. And so that is the length of the rectangle. X is equal to 90. Now, in a lot of these quadratic function problems where we're trying to optimize, we usually take our x value and we plug it back in to our quadratic function to find the y value. But in this case, the y value would be the area. And that I'm not looking for the area. The question asks for the dimensions that maximize the area, but it doesn't ask what that area actually will be. So we actually don't want to plug it back into this function. We want to plug it back into our other equation to get the other dimension, the width. And so we have 120, or excuse me, I'll start back over. Y equals 120 minus 2/3 x. This is where we want to plug in our value for x. So we're going to end up with y equals 120 minus 2/3 times 90. And again, I'll skip the details on working that out. Calculator would help you with that. What you should end up with is what you should end up getting is 60 for the width. So the dimensions that will maximize the area would be 90 feet by 60 feet.